Let's begin by reading the problem and highlighting important information. So compound interest is given by the formula A equals P times 1 plus R raised to the T power, where A is the balance of the account after 2 years, and P is the starting principal invested at an annual percentage rate of R expressed as a decimal. So this is the formula that we're using and what each letter represents. Now they're going to give us some values. So Michael is investing money into a savings account that pays 3% interest compounded annually, and he plans to leave it there for 15 years. So this is given information. I'm going to switch to green because I could see the question is coming up because it says determine. Determine what Michael needs to deposit now in order to have a balance of, I'm going to underline this, at least $20,000 in his savings account after 15 years. So notice I saw here that they were asking us to find what he needs to deposit now, but they also slipped in some more given information that they hadn't given us up here, at least $20,000. And that's going to represent the capital A, the balance of the account after 2 years. So let's just write what they've given us and what we need to find. So here's the formula, A equals P 1 plus R T. Okay. So now I'm going to just start with A because it's first. And they told us that they want the balance at the end of the 15 years to be at least $20,000, and that's what A represents. Okay. And I'm just going to put a little note here, at least, okay, because it didn't say exactly 20,000, it says at least 20,000. Okay. Now let's see capital P, which is the principal, the starting amount invested. So let's see where we can find that. Oh, we don't have it. That's what they're asking us to find. So it says determine what Michael needs to deposit now. So we'll use the letter P, and I'm just going to write unknown here. This is what we're looking for. This is our goal. Just going to circle it in green so we remember. Okay. Now we have little r. Little r represents the annual percentage rate expressed as a decimal. So they told us 3% or 3 out of 100, which is 3/100ths. So as a decimal, this is 0.03. And you can put that 0 or not. I like it because it helps me see where the decimal is. And now T. T is the amount of time invested, and that was given right here. And time in years invested. So this was 15 years, so we can just write this as 15. So now let's fill in what we know. So we want the amount to be 20,000 at least 20,000, so greater than or equal to, and we'll talk about that in a second, the principal, which we don't know, 1 plus the interest rate, 1 plus 0.03, raised to the 15th. So notice this represents the future amount, but this entire expression, this, is equal to the future amount. So we want this value that we're computing, we want to find the principal that makes this value greater than or equal to a future amount of 20,000. So now let's compute this. So let me start by, get rid of these arrows so we have some room to compute. Let's approximate this, but we're going to keep this stored in the calculator so we don't get any round off error, but I just want you to see what this is approximately equal to. So 1 plus 0.03, and I'm going to use this button for raise to the 15th. And we get this value right here. Okay, and again, I just wanted you to see that, so that's about 1.56. I don't want to round this now because depending on what the numbers are here, if the numbers are really big, it can affect your answer and you could be off by a few cents or possibly even a few dollars. But that's what that's equal to. So this is about 1.56. So this is about p times 1.56. About. So notice if we wanted to isolate p, we would just need to divide by this 1.56, or approximately that value. So we can actually do this in one step by dividing by this entire expression. 1 plus 0.03 to the 15th. We'll divide both sides. Now notice this is an inequality, so we do have to be concerned about dividing by negative numbers. If this number was negative, we'd need to reverse the direction of the sign. But we approximated it on the calculator. We saw it's 1.56, so that's positive. So this will cancel out. Now I'm going to go back to the calculator, and I'm going to compute this. You should put this entire expression into your calculator. 20,123,000 divided by, don't forget your parentheses, 1 plus 0.03, sorry, 20,000 divided by parentheses, 1 plus 0.03, close parentheses, and now raise it to the 15th power. And your calculator probably has a caret or an exponent symbol. This one uses this button here. So I'm going to hit equals, and we get this number. So let's write this. We have to, right now I'm thinking about what we have to do round to the nearest dollar and the fact that it has to be the least, but I'm just going to round this to the nearest cent for now. So 12,837.24. Okay, so this means the principal that we want to invest has to be greater than or equal to $12,837.24. And that makes sense to me. It's less than the amount that we're going to end up with, so the investment's going to make money over time, and that seems reasonable. Notice it says round your answer to the nearest dollar, and even though this is 0.24, I'm actually going to round this answer up, and here's why. Since we want it to be less than or equal to this amount, we need to invest enough so it will surpass the future value of 20,000. So if we did 12,837, it would actually be a little bit less than $20,000. So we need P to be a little bit greater than this. So the nearest dollar would mean that we should round up to ensure that P is greater than or equal to, to ensure that the future amount is greater than or equal to 20,000. Okay, so to make sure the future amount is greater than or equal to 20,000, we need the principal to be greater than or equal to this, and if we're going to round to the nearest dollar, rounding up would be 12,838. So 12,838.